In the Arduino Uno, you can only keep track of the passage of time by counting the milliseconds since power was restored. There is no simple way to convert the milliseconds value to an actual date and time. If real-time and date capability is needed in your project, you will need to connect an external clock module. The Arduino Zero contains a real-time counter feature integrated in the SAMD microcontroller. This counter can be used to implement an actual clock with the ability to tell the time and date, eliminating the need for an external component. In this lecture, I'll show you how to set up and use the real-time counter and use it to keep track of real time. Let's have a closer look. Hi! In this lecture, I'd like to talk about the real-time counter that is available inside the SAMD microcontroller that goes with the Arduino Zero. Having a look at the SAMD microcontroller datasheet, you can see in the second page that there is an 32-bit real-time counter with clock calendar function feature. This means that the Arduino Zero is able to tell the time, not just to count milliseconds since the device was turned on, but to actually tell you what time it is, what day, what year once you set it up. It's a very simple feature to use. There is a library that it allows you to easily make use of the real-time counter, and you can install it just simply by going into the library manager and searching for the RTC library. You can see that there is the RTC Zero library specifically written for the Arduino Zero. I've already got it installed here. Of course, you can install it if it's not already installed in your Arduino IDE. So to do a quick demonstration, I'll use this sketch. All it does is to first define current date and time. I should actually fix this so that it's pointing to today, which is for me is I think the 24th of March of 2016 when I'm recording this, and the time right now is 11:37 in the morning. Then you just set the time and date in the real-time counter in the setup function, and you can just print it out by just calling the relevant functions in the RTC object. So get date, get day, get month, etc., get hours, and so on. So it's very simple. So let's upload the sketch. I'll connect the Arduino Zero to the programming port. And make sure that the correct ports are selected here. So that's a board and my serial port there. All right, so upload. Okay, upload complete. And there's a real-time clock telling me exactly what time and what date it is. Of course, once I turn power off, the Zero will forget time and date. So let's try that. Disconnected, power lost, reconnected, so apply power again, and let's see what happens to the clock. I will open up again the serial monitor. And yeah, this is the time that I set in the sketch. So the Arduino Zero will start counting again the time as per the initialization in the sketch in the setup function. If you want to preserve the time, of course, you need to apply some battery power or some other backup power to the Arduino Zero. So this is something that you will need to consider when you build applications that make use of the real-time clock.